Meron naman tayo bagong module. Ito. Ano naman yan? Ito yung tinatawag na metal touch sensor. Kabit natin sa supply. Yung positive sa positive 5 volts at yung ground sa ground. Ground. This is the actual module. I traced the connection of the module and we have this diagram. After tracing the connection, we have now the schematic diagram consisting of two comparator, and this one is the touch pin. It is a Darlington transistor. Then we have the output, the one that is lighting, and then the power LED. For the pin out of the LM393, the IC, we have two comparator. Pin 1 out of the first comparator, non-inverting. Pin 2, pin 3 inverting, and then ground, pin number 4. Pin number 5 is the input of the second comparator. Pin number 6 the inverting input of the second comparator, and then the output of the second comparator, pin number 7, 8 is the VCC. It consists of 8 pins. In our circuit, we're using 5 volts. This is the power LED, power indicator of the circuit. And then we have 2 comparator, LM393. First comparator, second comparator, and then also we have the potentiometer, the 100K, and the touch pin, that is the one where we touch, the touch is a Darlington transistor. Initial state of the circuit, output LED turns off. When we touch the pin, it will turns on. It will on when we touch the pin. This is the pin. This is a Darlington transistor. When we touch the pin, the transistor switch on. The current flows from the 5 volts to the 100K to the 1.5, and then to the collector to the emitter of this transistor. So it will switch on, and also the output LED turns on. When we release our hands, our finger, it will turn off. Okay. We have 2 resistor divider, that is the voltage divider, connected to the pin number 3 and pin number 5 of the comparator. It will serve as a reference voltage. It becomes a voltage divider, so the voltage across pin number 3 is 2.5 volts divided the voltage. The 5 volts will be divided into 2.5 for the pin number 3, and pin number 5 is 2.5 volts. Initial state of the circuit, the current flows into the potentiometer to the 1.5K. And what is the voltage across this inverting terminal? Pin 2. It is greater than the pin number 3, the offset voltage or reference voltage, around 5 volts, because it receives a full 5 volts from the source. So the rule of comparator is, if the voltage, inverting voltage is greater than non-inverting input, the output is low. It becomes low, the output low, or low level, output low. If this is low, current flows into the 10K and then to the LM393. The 10K is pulling up and then pulls down to the ground. There's a pull up resistor. If this is 0, since this is low level, the output of the first comparator, it becomes low level here, and pin number 5 is greater. That is the non-inverting terminal is greater than the inverting terminal. The output is high, 1. That's why LED turns off, because the LED is reverse bias. It is high. It will only turn on if this output, pin number 7, is low or low level, or 0 volts or low level. But this time it's 1. So it will turn off the LED initial state. Okay, when we touch the pin with our finger, it will switch on the transistor, but it becomes a high gain transistor, because this is a Darlington transistor. Current flows into the 5 volts and then to 100K, 1.5K, and to the collector, to the emitter, to the ground. switching this transistor, that is the touch pin. This is the one we touch whenever we touch this pin. And now, what is now the voltage across the pin number 2? It is lower than this reference voltage. If the inverting terminal of the comparator is less than the non-inverting, it will output a 1 or high. Okay? If this is high, since 10K is connected also into the 5 volts, there is a high signal or a voltage output of high from the comparator 1 and plus the voltage across 10K, and then it will supply that voltage to the input of the another comparator. So this comparator now, the negative or the inverting input of the comparator 2 now is greater than the reference 2.5 volts. Since this terminal pin 6 is greater than terminal pin 5, it will output a 0. Since we have a high voltage from the input, it becomes low into the output. It inverts the signal. So if this is low, current now flows into the LED to the resistor, and this load is sourcing current, and the comparator is sinking current close to the ground of the comparator. The LED now turns on. What is the use of this potentiometer? It increases the sensitivity of touch. So when you adjust the trimmer, the potentiometer, it will increase the sensitivity. And the role of this resistor is, that is the load resistor or coupling resistor to the touch pin or to the Darlington transistor. Okay, so for the dual comparator, for this we have an offset voltage of 2.5 volts to the pin 3 and offset voltage of 2.5 volts to the pin 5.